Today's sponsor is Datadog, a monitoring and analytics platform for cloud-scale infrastructure and applications. Datadog provides seamless integrations with more than 400 technologies, including AWS, PostgreSQL, MySQL, Docker, so you can start collecting and visualizing performance metrics quickly. Distributed tracing and APM give you end-to-end visibility into requests wherever they go, across hosts, across containers, across service boundaries. With rich dashboards, algorithmic alerts, and collaboration tools, Datadog will give your team the tools they need to quickly troubleshoot and optimize modern applications. See for yourself. Start a 14-day free trial today by visiting datadoghq.com/HanselMinutes, and they'll send you a free t-shirt. That's datadoghq.com/HanselMinutes. Hi, this is Scott Hansel, and this is another episode of Hansel Minutes. Today I'm talking with Dr. Riham Mansour. She's a software engineering manager working in the world of natural language processing. How are you?
Oh, I'm good. How are you, Scott?
I am doing okay. I am learning and living and reading as much as I possibly can. And I'm excited to talk to you because I want to understand what natural language processing is, because it's linguistics, but it's computer science, but it's artificial intelligence. It seems like it's a Venn diagram of multiple disciplines.
Oh, you seem to have a lot of knowledge about it then. So so reality is, let's take the easy, simple definition.
Okay.
How do humans kind of connect and communicate? It's natural language is their power, right? It's the main power that we do have. Even when there is the face expressions, there is our gestures that contribute to how you understand what we mean. But the power of natural language and our ability and the ability of our brains to kind of put together, given the world vocabulary, some smart ideas that become like the innovations and all the nice literature books and whatnot. This is exactly the power, right? That humans can put together vocabulary that together make sense and add value, right? And describe things and whatever. So with that in mind, natural language processing is exactly the interaction between humans and machines. We're dreaming of a world where machines can understand natural language and has a similar power to humans understanding natural language. And here's why. Like, there isn't anything that can be better than talking to a human, smiling and joking and having all the gestures, which you might not have with the machine, right? However, there is a lot of the task completion work that we do day to day in our daily lives that if we get some automation out of, I think we can be more efficient as humans. So I don't think of natural language processing or getting computers to understand human language as a way to replace human connections and human interactions, because nothing can replace that, right?
Okay.
It is what makes us happy. It's how much we connect with people, our friends, our family, our kids. But it's more on like, how can we get more efficient by getting our machines to understand us the way I tell my coworker to do something, or I tell my friend to help me with something, or even give some instructions to my son on his homework or whatever like kind of task I'm after. And I use my natural language to describe it to the other human.
It seems like we spend a lot of time, and I've had this happening recently as I try to teach my children in a remote working world. We spend so much time trying to make ourselves understood. Like, I have intent. I have a thing I intend you to understand. I needed to get out of it, but I'm dancing around. I'm trying to find the right natural language in my vocabulary that fits the person's worldview so that I can get them to do what I want. I'm having trouble mapping the words in my mouth to getting them to say, yes, I understand what you said, and I know your intent.
Mhm. Yeah, I think machines are not as sophisticated as humans. The level the machine can understand out of natural language is way less sophisticated. I think human languages, when humans interact with, they are more for, yes, you're expressing your intent, and you might be saying, you're showing empathy, your tonation of the voice is helping you with some other aspects that would help the other human understand your intent. The machine is less sophisticated than that. It can make sense of the power of variations of natural language. However, it's not at the level of building that human connections. That you build with other humans, right? So that's why I said at the beginning, natural language has done a lot of progress. NLP has done a lot of progress in terms of using the compute power to get machines to be helping humans in their day-to-day activities and become more efficient. However, the effort on making human connections is still on its way. We will get there, like to help people with autism, or people who are lonely, or like
Hmm.
helping with these social interactions is coming. It's natural language is on its way, making progress in these domains, but it's not as much progress that we have today, like the task completion work, like where,
Hmm.
as you said, you're talking to your son, you want your son to do something, and you had an intent. This is very task oriented, if you think about it, right? It's
Okay.
not really like you're connecting or chit chatting with your
Right. It's
son,
not
right?
emotional. It's do
It's not
this.
exactly. It's do this. I think we have done a lot of progress on do this kind of work between humans and machines. We have done. We did a lot of progress as well on human connections, but it's not at the stage where it's like a de facto thing or something that everybody. It's not ready for for being a commodity yet.
Right. Another thing that I'm noticing is that as I use my Alexas and my Cortanas and my Google whatever, and I talk to these different things to say, do this, the way that I and my non technical spouse interact is, hey, I don't know, Alexa, thing, do this. And then it doesn't understand. And then I simply repeat the entire thing. It's as if I only get one chance. And then I reset and I attempt to call the function again, as opposed to what I'd like to do, which is clarify.
Hmm. Hmm.
There doesn't seem to be any back and forth. You get one chance to nail it and get it right, and then it's either wrong or it's not, and then you just try all over again.
I think we can do better than that in terms of technology advancement. I think we're at a stage in science where, things around asking clarification questions, conversing with humans the way humans are used to converse is get we're getting close to that. Like I would say, for example, especially with respect to do that thing, right? So if you're Cortana or Alexa, and if you're asking to play Michael Jackson, for example, on Cortana or Alexa, then you might. I mean, maybe your voice was a little noisy. It was a little soft. It was from far when you were talking to
Mm-hmm.
your Alexa. So if the device doesn't get the content, the audio clearly,
Mm-hmm.
then the translation from the audio to something the machine can understand becomes harder. And that's what the machine is good at, right? Given an
Right.
audio that you said, it takes that and passes it through a bunch of processing steps. And I can maybe give a high level description of what that looks like.
Okay.
But the thing is, if that processing, if the input is noisy, expect the output to be noisy, and the machine won't understand,
Okay.
right?
That makes sense. That makes
Yeah,
sense. And that's how it is in life, right? If I was talking to you now and suddenly that you start to break up, then you can't understand. And you have to go and build that back from scratch.
exactly. And the point is now that these machines are better at asking clarifying questions. Things like, "Did you mean this or that?"
Hmm.
I mean, it gives you more choices now because it faintly figured out what you're saying, but it needs confirmation before taking the action. right?
Right.
So even asking for confirmations is what humans do all the time, right? So we learned this behavior from humans. You tell your son, Can you grab me a cup of water?" And then if he was not sure, if she was not sure, they would go and get you something, and then, "Do you need any drink or just water?" Right? And then
Yeah.
they would
Yeah.
start. So the machines are doing better at that with some limited capability, but we should be doing more of that given the power of NLP that we do have today.
Right.
Yeah, let me get
In-
back a little bit to the stack of processing at a high level. Like what happens when I talk to Alexa or Cortana,
mhm.
right? So basically, what happens is I get an audio file, right, on the machine
Mhm.
or on the service, and then that audio file goes through a process of transforming it from audio to text, what we call automatic speech recognition, right?
Mhm.
ASR. It's a known technique for translating audio to text, because machines are better at understanding text than audio,
Mhm.
right? Some translation might be lost in the in that transformation, right? Because maybe I said, "Can you give?" I'm at the Starbucks and I'm maybe buying some coffee and Madeline, and maybe I pronounced it in a way that the machine did not figure out the right way, so
Mhm.
that the translation was lost in the middle, right? In that transformation,
Sure.
right? This is the first layer. Second layer, now I got the text. What can I do with the text? As you said, because you say do this, you want to figure out the intent, right? So for example, grab me a cup of coffee, right? So the intent is for the other human to give me something, but what that something is equally important as your intent.
Mhm.
Yes, the grabbing is the action that you want, but what is it
Mhm.
exactly that you want to grab? So it's not enough to know the intent. The natural language processing needs more than that, what we call entities. So, or like key pieces of information in your order or your
Right. So it's
yeah.
context, right? If I went into a Starbucks and asked for a pizza, it would take a moment for that person to go, "No, there's no pizza here." But if I order a kind of coffee, they're more likely to be successful and understand exactly what I mean.
Yes, correct. And not only that, there is more nuance to it.
Hmm.
As even if like the Starbucks person understand that you want a coffee, what type of coffee do you want? What options do you want to change on top of your coffee? What kind of milk do you want? Right? So there is a bunch of things that if you really want a good service, the same way a human would do it to you,
Hmm.
then you are really at a point where, oh, I need to identify all these pieces, right? Same when you tell your son to grab a specific thing for you, and maybe your son would ask some questions to get more details, right? And these details matter in how good the task completion is, or the result you get out of the machine is.
Interesting. Okay. What about when things get mixed up? If I go to order a coffee and I say I'd like a café con leche, when I'm mixing English and another language, do you have, can it glean that? Can it learn that? Or does it need to have all that context up front?
Oh yeah, I think the power of machine translation as well as natural language processing, we are at a point where we can mix and understand the different languages, even if they are mixed in the same sentence. It becomes harder on the machine. It might take more processing power and whatnot, but
Hmm.
it's pretty doable.
Wow.
Mhm.
Okay, so I say something like, give me a coffee. That audio goes through the processing. It turns into text, a query that then says in a string in computer terms.
Mhm.
Uh, does it have a confidence? Does it say, well, I'm 90% sure that that's what they said?
Yeah, good question. So it depends on how the models in the background have been built.
Hmm.
So there are two ways of processing text or doing AI. Because this is artificial intelligence, right? For machines to understand human language, this is artificial intelligence.
Hmm.
So there are two ways of doing things, and there is a hybrid between the two. The first part, which has started very early in, I would say, the 60s and 70s, is what we call rule based systems. So behind the back of that Alexa or Cortana, there is a bunch of AI models. that are understanding the intent of the text, that they understand the key pieces like the entities we talked about, like what type of coffee do you want and what milk do you want and so forth. So these models are either a bunch of rules, because you might argue that I know all the list of coffee that a certain coffee shop is offering. Right? We're not confused about that. They have their menu, and if we're building that for a specific coffee shop, then probably they know what they offer, and we might have that list, a bunch of strings, and I do exact match, right, between what the user has said or the text that I got from the processing and that list, right? So I call this rule based because it's based on rules, right? It's not super smart. It's like either you match or not, or I might build regular expressions, right?
Hmm.
Things like assume you're asking me about my phone number, right? My phone
Hmm.
number can be easily detected with a regular expression, right? So these are all rules that if we put together, we will they are deterministic. With rules, I mean they are deterministic. Like given the same input, I will get every time the same output, right?
Hmm.
Then the other school of thought here for building these models is statistical models. And
Hmm.
statistical models is the way machine learning works, right? So many people hear about that word machine learning. What machine learning is, it's using statistical models to make probability predictions, right? So basically, what we do in probability-based models or statistical models in the natural language processing context is we get the machine to see a bunch of patterns upfront, right? A bunch of patterns that it can see in real time, right? So if I'm building a pizza ordering system, then I would show the machine a bunch of different ways of ordering pizza, right? Different ways customers would order pizza, different pizza options, and different toppings and whatnot.
Hmm.
Then train it for some time on that. Then build a statistical model out of that. That when put to real traffic, real orders, it will say, "Oh, you know what? This is probably a pepperoni pizza with a confidence score of a 90%."
Hmm.
Right, and this is the topping here is vegetable topping with a confidence score of 84%, and so forth.
Hmm.
And why are we generating this like a prediction score or confidence score? It's because the system is built statistically, right? So given the patterns it has seen at training time, when we trained the model before we put it in action, how, given that knowledge about the world, how much do we anticipate this new order that I haven't seen before as a machine
Hmm.
it would be, right? That's basically what it is. That world of machine learning, alongside with the world of rule based, are mixed together to build a very highly efficient bunch of AI models for natural language processing. And here's why. Like, while there is a huge power in statistical models, there are many, many problems that we can be easily solved in a deterministic way as well. So I don't think like there is one solution versus the other. Machine learning is a more scalable solution.
Hmm.
It covers a larger set of patterns. It can deal with uncertainty that comes
Hmm.
in real orders. Like for example, if the machine hasn't seen that pattern of an order before, it can still generate a prediction score for it with some confidence, given that it relates to other patterns that it has seen. So it pretty much works similar to how humans work, right? So if you're new to a new pizza restaurant, right,
Hmm.
and it's your first time to see a pizza with broccolis, for example, you haven't seen that before as a human, how would you react to that? You would try to relate it to the closest possible reference point you had in mind, which is any other pizza with any vegetable, right? And from that perspective you would anticipate, oh, probably it would taste well, let me try it, right? So
Hmm.
that's exactly what the statistical models are doing. They try to relate to the nearest pattern they have seen and statistically generate a score for that, for the machine confidence in that prediction.
That makes me wonder if we as humans, or myself as me, I'm probably internally keeping a confidence score when my wife yells something down. I am 85% sure she said this. I don't actually think that consciously, but those that confidence number is there in all of my interactions with natural language and as a human.
Oh, absolutely. The machine is not far from how you operate. It's just that you're smarter. You have
So
way
far.
more, yeah, you have way more knowledge about the world than what the machine has. The machine has to be told what knowledge it would have, but
Okay.
you as a human with education, with interaction with other people, and that's why we have difference in levels of knowledge between people across their ages, right? You haven't had the same level of knowledge 15 years ago or when you were a kid in school, right?
No one wants to manage databases if they can avoid it. That's why MongoDB made MongoDB Atlas, a global cloud database service that runs on AWS, GCP, and Azure. You can deploy a fully managed MongoDB database in minutes with just a few clicks or a few API calls. MongoDB Atlas automates deployment, automates updates, handles scaling, and more so that you can focus on your application instead of taking care of your database. You can get started free at mongodb.com/atlas. Now, if you're already managing a MongoDB deployment, Atlas has a live migration service, so you can migrate it easily with minimal downtime and then get back to what matters. Stop managing your database and start using MongoDB Atlas. This is really significant because I've got a 12-year-old and a 14-year-old, and they've just in the last 2 or 3 years, and I think you may have had this experience as well, when your child suddenly knows something that you don't know, when the sum total of their existence is more than you. My 3-year-old, when he was 3, he only knew everything that I told him. He had no context outside of what we fed him.
Hmm.
And now the context of a 14-year-old or 13-year-old is massive, and they're telling me things I've never heard of. Where did you pick that up?
You're bringing a very interesting point here. If I map this to how machines work, there's an interesting analogy that we can draw here. We machines and statistical models. If we take the machine learning route, which is most of how we scale our AI, it's like yes, they look at some knowledge, limited knowledge at the beginning.
Mm-hmm.
That's what you train them on. But once you put them in action and they start seeing real orders in the pizza shop, right, over time, they would get to learn more and more. Like they will get more knowledge if we reuse some of that traffic back in the model and re-educate the model given what it has seen in real life. And that's exactly how your son operated, right? When he was only at home or in the nursery, when his scope of visibility to the world was very limited and controlled by you,
Mm-hmm.
that gave him a limited set of pieces of knowledge. But
Mm-hmm.
then once he went into school and like to the exercise and to the swimming game and whatnot, then he started interacting with more people, gaining more experiences and learning more information, right? And basically you've deployed your son in real life. The same way we deploy, yeah, the same way you deploy the model after you train it in reality in production.
And this model, this child that I've deployed, has the implicit ability to absorb and grow, while a
Exactly.
model that remains static does not. So we have to decide whether or not we want these models to grow or not.
But that's exactly where the human is very needed in that circle of building natural language processing systems.
Mm-hmm.
So, like I'm working in the past 5 years on a system called Language Understanding Service, which is part of the Azure services for AI.
Mm-hmm.
And that system is based on technology called machine teaching. And machine teaching is a bit different from machine learning in the following sense: it's a new way of building machine learning models. However, it pivots on the human being part of the loop, because we always think that for many problems the knowledge is in the human experts rather than in the data. We don't have lots of data for many problems. There are problems we do have lots of data for, but there are many other problems that we don't have problems enough data for. And for those problems where we don't have a lot of data, how would you build an AI model that understand the world? How would you teach the machine? Right.
Hmm.
So the only way is to create a new ecosystem where you teach the machine the same way you teach humans. How do you teach humans? You teach humans through a language. So, in the language understanding service that I'm working on, we create a new tool for developers and domain experts to come and teach the machine about their domain expertise in a way that with an easy language, with an easy interaction with a portal, where you end up building an AI model, even if you don't have a lot of machine learning expertise. So, sorry, I talked a little bit more about the service I'm working on, but the meta point I'm trying to make here is the model will always be static because the machine is not proactive. The human has
Hmm.
to come back in the loop and decide to improve the model based on the real traffic after the model got deployed.
Hmm.
This is the difference between the model when deployed and your child when deployed, because your child has that feedback loop happening naturally, but the model won't have that natural. Right, the human has to come back, the human expert has to come back and say, hey, these are the examples of orders
Right.
that my system did not predict well, or the customer was not satisfied with because we did not get the order right, and then I have to fix that.
Right, right, right. And when my son is deployed, I love that. I'm going to be using that all the time now. When he goes out and he collects knowledge and comes back and then makes declarative statements to me about how the world works, and we go, well, and we try to gently adjust his belief system. That's one way, but you might want to think about it this other way. That's where that feedback loop happens. He then changes his model, deploys again, and comes back and preferably and hopefully becomes a better person as he iterates through this machine learning slash machine teaching process.
That's exactly right. And that's how humans are a crucial part of building a model that adapts to the world. Because imagine, like, even when you deploy a model at first, the semantic of the problem changes over time. Like pizza orders, for example, have changed over the years. We've come across new toppings, we've come across new crusts, we've come across. I'm picking a very small example here, but the whole definition and semantic of what forms a pizza has evolved over time, right?
Mm-hmm.
Maybe not significantly, but slightly, right? And how can you get the like people to keep accomplishing the same task interacting with the machine if the semantic is changing, or if the distribution is changing, or even if the language is changing? I'm sure you've come across that the type of words that we used to use when I was a kid have the vocabulary has changed a little bit over the
Mm-hmm.
years, and the way I now express something, there's a bunch of sayings that are very when you say it to a human, they will understand what you mean, although it doesn't mean literally the words, right?
Mm-hmm.
So that is what we call a change in distribution of the data, right? Because when you train the model the same way when you teach your son some concepts, if these concepts change in the world, your son adapts because his mind now collects what we call more labels. He sees more examples, more
Mm-hmm.
patterns, while the model is seeing those. But the best the model can do is to relate the models, the new models, or the new patterns to the nearest possible pattern they have been trained on. And
Mm-hmm.
unless you update your model with new trained examples, including especially the vocabulary, right? The slang vocabulary, the new words, and the new trends, even the new names of singers that appear in the world, the new albums. Like there's a
Mm-hmm.
lot of update of information that is happening
Constant.
in the world. Exactly. So how do you expect your model to learn about all that when deployed after 10 years?
Okay.
right?
Let me ask then an incredibly naive question. Let me take this problem and invert it, because people might be listening and thinking, well, my area, the bot, the thing, the natural language device bot that I need to create is so constrained. It only needs to know about 10 words or 20 words. It only needs to express, turn this on and turn that off. Why can't I use a simple off the shelf library, figure out that I got a string out of this and a switch statement? How quickly does that fall, where you have a deeply constrained vocabulary of possible intent? How quickly does that fall over?
That will fall over very quickly if you rely on because basically you're diminishing the power of natural language. People don't
Mm.
expect people to talk to your bot in one way or two ways or five ways. If you get your bot to be deployed to help people with I don't know, questions about packages in their internet connection,
Hmm.
right? How many ways do you expect your customers to be asking the same question while they mean the
Well,
same
yeah,
thing?
they're all
Many.
different, so they'll ask many different ways.
Exactly, right. If you decide that, oh, you tell the human, like IVR systems, for example, this is how we started, right, in the 80s.
Right.
Right. So if you go back a little bit in time, you see that we've tried to simulate that, but we diminished the value of natural language because back in the time we did not have enough technology advancement that would lead us to do what we do today with natural language. So in the past, IVR gives you a bunch of options, and it's
IVR is an interactive voice response. It's talking to a bot on the phone, right?
exactly, and then it gives you a menu, and you cannot say anything outside that menu. Right.
Hmm.
And you even choose the menus with numbers. Sometimes it's not even that you express the word in the menu. You have to choose a number because it's easy to interpret a number than a word that is open ended, right, or like generic.
Hmm.
So with that era is kind of uh, over, and we are in a new era where natural language can be understood by machines given the statistical models and the advancement in machine learning. And back to your example that you said I can write a switch statement and put it deploy it to the world. That won't be far from what IVR could have done, right?
Hmm.
But if you really want a bot that simulates an agent that I'm talking to, then it's a different story because you cannot anticipate how many ways people would mean the same thing, would say different things to mean the same thing, the same intent or the same number of context words that make that intent understood by the machine, right?
So it sounds like, from the point of view of a developer who is interested in this space, of course, they could dig deeply in it, get a PhD or multiple PhDs in this space. But if I want to be a user of this, language understanding as a service is a thing that exists. I could take advantage of this power without understanding it as deeply.
Mm.
Uh,
That has been exactly the reason 5, 6 years ago we've started that project of the language understanding service that became later a product that is part of the Azure products for AI. That has been exactly the motivation. I think AI has been limited to people who have PhDs in the past, and that limited what we can do as a community and as a society to push the boundaries of how technology can help humans in their day to day. Right? That was a
mm.
limitation, a huge limitation, because how many PhDs do you get every year? And would every company be able to hire those people? Because those people typically would go to other, like the tech giants, and work for them. Right? So, how much can we do to scale? Basically, this is the question, and that question has been bothering. So it's like growing a plant. The first stage was can we create the science to get machines to understand natural language with different variations? We spent 20 years doing that, right? And then we got to a stage where, oh, we can do that, but only people who really, really have deep knowledge about machine learning and natural language processing who can do this. Oh, now the next stage is how can we enlarge the base of users who can build these systems without that knowledge. Now we're at that stage. And I think that's why, for example, we got to work on that machine teaching technology 15 years ago. And it became apparent after 10 years that it's ready to be deployed to some users, and that's how we created the product. But the goal there was to democratize natural language processing so that bots and automations can be possible for regular developers, people who want to, even business analysts and domain experts who really want to automate some of their workflows.
Fantastic. And folks can learn about that at Luis,
.ai.
LUIS.ai or Luis.ai.
Yes.
Thank you so much for chatting with me today.
Oh, thank you. That was very entertaining.
I've been chatting with Dr. Riham Mansour, and this has been another episode of Hansel Minutes, and we'll see you again next week.